everyone, in today's episode we are gonna continue with our big end-to-end Python deep learning project, when we are helping the local farmer Jamil to decide which of his tomatoes is healthy and which is not, according to his tomatoes images. In the last episode that you can see on my YouTube channel, go watch it here, we explained the purpose of this project, we set up the project, and now it's time to write some code. Let me just show you what we done in the last episode. We created this folder in our episode, we downloaded these images, and we just set up these directories. This episode will be about preprocessing and storing your data. This will be our final product that you can tweak and use in any of your future AI projects. We will go through many important things like importing the required libraries. We'll explain why, what and when to use. Then we will store our data into Tensorflow dataset. I will show you how the Tensorflow dataset looks like, what is his built-in functions, and then I will visualize images in this dataset. And lastly, we will split our data into training, validation and test dataset. This is a very important step in any AI project. But we will do also a little bit more things, like this one, but you have to watch the video for it. So hit the like button, smash subscribe and share with your friends. And without further ado, together we can make history. We can begin with data preprocessing. First thing you need to do is locate your folder, where is your project stored. Copy the path by clicking here, Ctrl+C, and open your favorite terminal. Write here cd for change directory, paste the path, press enter. Now you can write Jupyter Notebook, because you installed this Jupyter Notebook library in the previous episode. If not, come back to the first episode and do it again. Press enter. Now it will open your Jupyter Notebook with Jupyter Notebook file we created in the last episode. In this folder are images from the tomatoes, and here are our tomato model, Jupyter Notebook. The first thing, if you wanna write the note, you change this code to markdown. You do it like this, and write like titles by writing here hashtag importing required libraries. Shift plus enter, you run the cell, or you can press this, play, like you see here, play, and it is done. Now you have code. I will import few libraries. First one will be import TensorFlow as df, also NumPy, as np. TensorFlow is used for many machine learning and deep learning tasks, but mostly deep learning tasks. NumPy is for numerical calculations. It calculates a lot faster than a basic Python. Then I will use matplotlib.pyplot. splt is for visualization of your graphs, images and so on. The next library will be import tensorflow.keras, and from that, okay, not like this, from tensorflow.keras import models and layers. The main reason of this keras sub-library of TensorFlow is to create your own neural networks. The last one will be IPython. From this IPython, I will import HTML. This is for visualization of different media in your Jupyter Notebook files. Press shift. Okay, now I will run the code by pressing this little arrow on the code, and the code is running. Just wait few seconds to be finished. Okay, it's the code ran successfully. Now we have all required libraries. We can continue with storing data into Tensorflow dataset. Press Shift Enter. Now still code. Here I will define two constants. The first one will be batch size, because we are not able to load 10 million images in one batch to our RAM. We need to divide these images into smaller batches, and then we can load one batch at a time. For our batch, one batch will have 32 images. Image size is, if you can check here, training, you can check here, for example, this tomato, the image size is 256 times 256. This applies for every image, but just in case we can specify that our image size will be a tuple. Why tuple? Because tuple we couldn't change tuple, so it will be 256 times 256. Run the cell, create another cell. Here I will store our data from this folder into TF dataset. You can check the documentation of Tensorflow. You see TF keras preprocessing image. You can, but we don't need this one image. We need image dataset from directory. Here, copy this. Like you can copy like this line. Put it here. We will store this into a variable or object called dataset, and we will put some parameters here. As you can see, first one, specify directory. What is the name of your directory? Is it blend village? Write this here with blend village, comma. What else we need? We don't need labels and stuff like that. We will use batch size, image size, shuffle and seed. I can copy this a bit, I don't want to write. It's much faster. Press enter. The batch size is here. Constant specifier. Like higher is equal to the batch size. The image size will be image size. Shuffle will be true and seed will be, for example, 24. Why we use this seed? Because we need the same result every time in our model to show you that it is working. But you can put random seed, or if you don't put any seed, it will produce different result every time you run the code. I think that's okay. Now you can run this cell by pressing Shift plus Enter or this little arrow. You see, this pre-processing tool found 16,000 images or files belonging to 10 classes. It is this directory. There are 10 subdirectories. All these directories contain 16,000 images. Why did we use the Tensorflow dataset? Because it is a very powerful dataset that can handle enormously large dataset by loading it with the batches, and also it contains a lot of built-in functions, for example filtering the data, mapping and so on. So this is a very useful tool. It's very good to know about this tool. Now, for example, I can show you that this dataset can automatically write you the names of these classes. Just writing dataset.class names. I will store it into variable called class names. New line, class names, and hit enter. You see you have all the diseases from here. Tomato target spot is the first one. this is in alphabetical order. Yeah, but I think it is called alphabetical order. And you see what it is here. Target spot, and this is healthy, and there are all other diseases. Now if you write the length of the dataset, it will write to 501. It is question for you, why it is 501 and not 16,000 images. I will wait a few seconds. You can pause the video and think about it. Okay, it is because it is the length of our batches, not only the images. If you multiply, one batch contain 32 images. If you multiply 501 multiplied by 32, it will give you 16,032 images, and it is a little bit more than this, because you need to create a new batch, not just a part of the batch. That's why here is 501. We store this data into TensorFlow dataset, but how does the data look in this TensorFlow dataset? I will show you for image batch, label batch in dataset is our variable for TensorFlow dataset. I will take one batch and I will print out the image batch like this, print out, and you see there are a lot of numbers and you don't even see like what is this. So we press here that shape, press enter. Now you have 32, 556, 556 and 3. What are these numbers? These numbers are 32 is the size of the batch. These two numbers is height and width of the image, and the 3 is the number of channels of one image. That's the RGB, like 3 numbers that represent each pixel. Also, I will print out the label batch. That's the label, like which disease from these directories has that image, or it is healthy, for example. Okay, so I cannot print it like this because it will print TensorFlow object, but for better visualization I will use NumPy. You have now only a list NumPy array. So it is like, for example, first image in this 32 batch there is in the 7th class. You see it's only in the 0. Okay, this is indexed from 0, so this is 8th class and this is the 10th. But you know. Now we can, for example, visualize one image from this dataset. Visualization of an image from the PF dataset. Here I will write the same for loop for image. If you write the same for loop, so just copy the first line here, and now we use this matplotlib.pyplot to visualize one image from here. PLT stands for this library, image show here. We will use this image batch from here, image batch. We will take the first image, transform it into NumPy array. Okay, this NumPy will transform it into NumPy array, and also I need to this function expect the integer, so I will transfer this NumPy array as type here in unsigned integer here. The size is 8. Okay, now plt.show, run the code. Okay, something is wrong. Okay, here is missing the parentheses, and we got random image. If you run this again, you get another image. If you run this again, you get another image. Okay, you got it. I think we got it. And there is one missing constant. Epochs will be 50. One epoch This is constant for training our model in future episode. One epoch means that in one epoch the model see every image once. If you run the training of the model twice with 2 epochs, the model saw every picture twice. That's all. We have all dataset stored, but we need some data to train the model, then validate if the training goes well, and then also test on the new data if it's not overfitting our training data. Now for this, markdown, we'll create train test split this, enter, and it will go like this. 80% of our data will be training set, 10% of our data will be validation set, and 10% of our data will be test set. I will use here like PR for break line, like new line character. We use these partitions because we need to, as I said, we need to validate the module and also test it. Enter. Now we can create a function for this. We can reuse it more easily. I will call it get partitioned datasets. Here, first parameter will be dataset, the next will be train split. It will be the 80%, so for our case 0.8. The val split will be 0.1 and test split will be 0.1. We will also shuffle the data because we don't need like first 8 directories to use for training, this one with the same disease for validation and the last one for test. So I will use shuffle is equal to true and not supply, shuffle size is 10,000. Okay, if I will return the train dataset, val dataset, the test dataset. This shuffle size means the size of a buffer, like how many images this shuffle will take at once. Like this. Here, space, if shuffle, the dataset will be equal to dataset, use the shuffle method, dot. This is also, the shuffle is also from this TF dataset. It has a lot of built-in functions. Shuffle, here, shuffle size and the seed to produce the same result every time. I will use 10. Here we will use 2 functions. Take, it will take the number of batches we will specify here, and also skip, like dataset.skip, like here, dataset.skip, it will skip number of batches you will specify here. The first one, we need the length of our dataset, so dataset underscore len is equal to len of our dataset. We will put into this function. The training dataset length will be an integer, and it will be multiplication of train split times the dataset length. Here, the train dataset will be equal to the dataset that take the number of batches this calculation will produce. So train underscore length, and we need to dataset is equal to dataset that keep this we need to skip these batches we put into the training dataset. Train. Okay, we will do the same for validation. Like validation dataset length will be the integer of val width times size. Dataset length. Validation dataset will be the dataset is skip the batches and now it continues from the new batch. So dataset that take the length of the validation dataset and we will skip this batches now. Dataset that skip validation length. I think I have a mistake. Oh. Oh, okay, maybe no mistake. Okay, the last one is test len, and it will be dataset len because we rounded this into the whole numbers. This won't be like exactly 10%, but it will be like 10.2 or something like that. So dataset length minus the train len minus the validation length. And here dataset not test dataset will be equal to dataset that take the test length. We run this function and we will create three variables: train dataset, also val dataset, and the test dataset is equal to, we will call the function and return the results into these three variables. Get, I will just copy, why not, and put here our dataset. This dataset is our Tensorflow dataset object. Run this, everything fine. We can now print the length of our training dataset. It is 400, so it is almost, our length of our dataset is 501, so it is 80%. Now the length of our validation dataset and also the length of our test dataset. So it is approximately like 10% and 10%. The last thing we need to like little bit alter, like tweak the datasets so it works faster and more efficiently. So train dataset will be equal to train dataset. We will use function cache. This will load the dataset and it will remain loaded after one epoch of training your model. That shuffle. I will also again shuffle the data, but this time in smaller pieces in 1000 blocks. And last one will be prefetch. This means if the model will be training on one batch, yeah, it will, for example, GPU will be training one batch and CPU in the same time will be loading your next batch, so it will take less time. And the buffer size for this prefetch will be set up automatically by Tensorflow. TF data auto tune. Now I will use the same for validation and test dataset. Here validation small, here it is validation, and the last one will be test dataset. Run the code and everything should be fine. In this episode, that's all for this episode. The next episode we will create our neural network and we will also train this neural network. Maybe we will do some simple predictions to show you that it is working or not. Then we will continue with the other stuff of this project. So hit the like button to don't miss the future episodes. In this episode we pre-process the data, store the data, and do some splitting into smaller datasets. I think that's all. If you have any questions, write them in the comment section down below. In the bio there are all links that you need for this tutorial. And what else? Hit subscribe button here and have a beautiful rest of your day. Peace.